is Gregory Stanek, and today I'm going to be talking to you about how volcanoes form, how they erupt, and some features that they have. So behind me on the whiteboard, I drew a picture of a volcano. You can see it right here, and here's your surface right here, and then below is your magma chamber with all of your magma. Your magma chamber is going to be known as plutons, and they're going to be like these little, not little, they're going to be large, areas of magma, and then they're actually going to be interconnected, and when they're interconnected as a whole, they're known as a batholith. And then, as the magma rises, there's a couple different things that can happen. First, you can have a laccolith, where the magma will come up, and then it kind of starts to spread out on both sides and form a bulge. And you'll actually be able to see this bulge on the land. I haven't drawn it here, but this would kind of be bulged up as this magma pushes up on the Earth's crust. The next thing that can happen is as the magma rises towards the chamber, which will be right here inside the volcano, it'll rise up and it'll start to spread out in as it hits rocks that are going to melt. It's going to melt them. More silica-rich rocks are going to melt, more felsic rocks. So the rocks above and below this little branch off of the magma are going to be more mafic than this. So this is going to melt, and when it melts and it moves in any direction other than perpendicular to the ground here, it's going to be known as a sill. So these are sills right here, and then any angle, as long as you're not at 90 degrees from the ground, is going to be known as a sill. So you have a sill here, 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 and then when it's 90 degrees, it's known as a dike. So what's going to happen is it's going to keep melting. There's going to be pressure building up below it. There's going to be a lot of energy, and all of a sudden there's going to be cracks forming, and the magma is going to move into the magma chamber, which is right here. Go ahead and draw this in real quick. So this is your magma chamber, and it's not a chamber in the sense that it's always hollow like that. It'll kind of form as the magma pushes up, and then the magma will come up and erupt. There's a couple things that can happen based on the type of magma. If you have a more felsic magma, it's going to have a lot more silica, which is going to have a lot more SiO2, which is going to bond to itself and create a more viscous magma, which is going to explode with a lot of great force. And then on the other end of the spectrum, if your magma is mafic or ultra-mafic, it's going to be more runny, and it's going to be like what you see in Hawaii, where you have this volcano just constantly erupting, and the magma has the consistency of almost liquid. So those aren't very violent eruptions, as opposed to the more felsic minerals. Another thing which will contribute to how violent an explosion is going to be your dissolved gases and your volatiles that are within the magma. What is basically happening with the felsic is you have all these dissolved gases, CO2, H2O, I think there's sulfur dioxide as well in there, and it's trying to get to the surface because it's less dense than the source or the magma around it, obviously, and the felsic magma doesn't want to let it out because it doesn't really want to flow very well. So what happens is when these giant bubbles finally get to the top, they throw the magma everywhere and things explode and rocks go flying. So what we're going to do now is I have created a jello volcano right here. It kind of broke. I don't know if you can see it very well. And so it kind of looks like this, but we're going to shoot up some magma through it, and we're going to see if we can see some of these features. Okay, so here again is our volcano, a little bit of a different view. And I'm going to go ahead and insert the syringe with my food dye, which is going to represent my magma underneath it. And I'm going to slowly increase the pressure and see if we can, again, see some of these features which I described earlier. So give me a second here, let me get situated. Okay. So if you're doing this on your own, it's important to make sure that your lava or your food coloring has been chilled. You don't want it to actually melt the jello because then it's going to act a little differently. It's basically just going to move straight through it rather than create any of these features. So there's also a lot of leakage with it. So I'm doing this over a sink because I don't want to get red food dye everywhere. So okay, I just shot the first amount in. It was about 5 milliliters. And I don't know if you can see it very well, but there's a little bit of some some lava flow in there. It's kind of leaking out a lot, so I'm going to see if I can move the volcano when I shoot the next amount in. Let me go ahead and get some more here real quick. Okay, and then let's move this volcano a bit. And we'll cut this open later and see if we see any of these features. You'll notice I have a lot of food dye in my hands. And I might actually change syringes because this one doesn't go very deep, but we'll see about that later. Okay, so let's go ahead and shoot this back up there. And okay, so I just got a larger syringe, so we're going to see if this works a little bit better. Another precaution you might want to take, which I didn't take at first, was to wear gloves, and now my hands are all red. So before any angry mothers call me and tell me, you know, that their kids have red fingers or whatever, I guess I'll just add that. Okay, let's see if we can go ahead and move this again, because the last time it just leaked out the bottom, which isn't at all what I want it to do. I'm going to apply a little pressure up top and see if I can get it to kind of stab in a little bit better. Okay, and let's see if we can get this to work this time. So I'm adding the magma, and it is now it entered a little bit. Most of it leaked out, but let's go ahead and cut this baby open, and I'll show you some of the cool features it has. Grab my knife. Okay, so when I initially shot it in, it started right there, and it kind of formed a laccolith, which if you remember, it comes up and then it forms like a little dome shape. It didn't actually make the jello deform at all because really there's nothing behind it. It's just a little bit of liquid. But I think you can see a little bit right in here. Let me see if I can cut it through this. Okay, well, you can't really see it very well, but grab this. But right here you can see it came up, and so it came up a bit, and it kind of bowed like that. I guess my cut wasn't exactly the perfect one for that, but hopefully you get the idea. Right in a little bit past that, so I can cut this one out a little bit better. Cut a cube and see if we can maybe keep the entire feature in there. Okay. So you can't really see very well because there's a lot of red food dye in here, and I'm sure the camera's not doing this justice. But the magma actually did shoot straight up like my hand is right now, vertically like this. And it kind of formed a dome again, but then it started to shoot out a little bit from the sides as well, creating some sills. And obviously the dike was the one that ran perpendicular to the ground, which in this case is right here. I'm going to try one more thing. Let me go ahead and grab my syringe again, get a little bit more magma in it. Okay, and I'm going to try to shoot it in from the side right here, and just see if I can't maybe get a little bit better of an angle, and see if we can show you some more of these features. Okay, so syringe is in. Let's start shooting. Okay, yeah, no, I can't really get a better angle. Unfortunately, I don't have a syringe that's really long enough, and most of this red food dye is just leaking out. So before I make any more of a mess and have to clean up, all this red food dye, I think we're going to call it a day, and see you next time.